Hi folks, welcome. Today I'm going to show you not only how to make yourself at home very huge LED, almost bigger than my face, but I'm going to teach you how all these LEDs that looks the same can change light, color. One is blue, one is red, and what's happening inside. So let's get started, but first, intro!
Let's start to make a mold of an LED. So I imported a picture of a real LED and I follow using a pen the shape of the outer line of the LED. So basically I'm just designing half of it, and using the rotary tool of Fusion 360 I ended up to have a rotational shape of the original shape I just drew. So this is the object I need, and you can clearly see that the LED stays perfectly inside. This would be quite big, bigger than my hands, and I'm just have to add 3 little feet, not only that works as a stand, but maybe I have to install it inside the lathe, so these are necessary. To print the mold I can use any kind of 3D printer, but in this case I have this one. It is a RESIN 3D printer and can print in maximum resolution. This is important because the mold has to be all smooth and shiny, so let's hope that this will work. I can pour this resin, that is a special one. It cures when it's exposed to UV light. On the bottom part of the tray there is a little monitor that will project pictures that create each layer that form the object itself. These layers sticks to this aluminum tray and can move up and down rapidly. Almost 2 seconds for each layer and took 12 hours to have the final result object. I'm going to sleep and hope that everything came out great. And finally, this is the best moment ever. Each time I can have finally in my hands the object that was before just in my mind. And you can clearly see that everything went well, but maybe there was something missing in the file. I don't know, maybe I made a mistake, but isn't perfectly round, isn't circular. We have like polygonal faces here, and this is bad. We never seen an LED that has this shape. But let's try to fix it. I can wash the part into alcohol mixed with 20% gasoline, will remove all the excess of resin, and I can cure it using a UV light. Let it spin for about 8 minutes, 10 minutes. Also all the resin is cured and I can try to sand it smooth. This is important, otherwise the resin will stick to sandpaper.
Sincerely, I don't know why the object came out not round, but with all these square corners, and it's terrible because this is a mold, and if it's all squared up, the mold itself will represent the same shape. I don't know if it's a problem of the file, the 3D file I exported from Fusion 360 that has all these square faces, or maybe is a problem of the resin 3D printer that I don't know why if you put a circle it square up the corners. I don't know, but I can solve the problem with some sandpaper. In this case I have an old lathe I connected to a washing machine motor, and let's start to sand it and smooth everything from the inside.
It's so important to remove all the imperfections from these components, because all of them will be represented as well with a transparent epoxy, so everything has to be smooth and shiny. That's the reason why I installed the lathe here, and I designed in the Fusion 360 program these 3 parts of the base so I can mount them inside the chuck of the lathe. I connect everything to the motor of the washing machine, and it is very important to use a not powerful enough motor. It's barely powerful enough to let it spin, but in any case if I crash with my fingers everything will stop and I will not hurt my fingers. So be careful when you do this kind of job, can be very dangerous. Powerful lathe can cut fingers without problems. I will focus to sand perfectly smooth the inside part of this component, but also the outside, so we can see clearly what's happening inside. I pass gradually from a very rough sandpaper to a smaller one, in this case a 4000 grit sandpaper, so everything is coming so great and smooth. I also added some water, but now let's put instead this, that is a fluid to make metal shiny back again. This contains aluminum oxide powder, very small one, and is great not only for polishing metal but also to make things shiny back again. I use some cotton cloth inside and I work it for about 5 minutes, and this is the result. Everything is shiny and this looks like glass. It's amazing, really. But now let me tell you how an LED works and what's happening inside of it.
All these LEDs look the same, but I can turn them on with different color. How is this possible? If I look inside, there's no color. So what's happening inside? These are called LEDs and are diodes. They work exactly the same like diodes, so they let current and tension pass in only one direction and not backwards. And graphically are almost the same if you draw a LED diode and diode. This, for example, is a simple diode, and you can see the schematic how it's represented. And this instead is an LED diode. These produce light and emit light, and that's the reason why we have these two huge sparks of light coming out of the sign, the graphic sign. So you can understand that an LED and a diode are almost the same. And let me tell you something that is so interesting, are exactly the same. Also the diode, this black component that is used in almost every circuit board, is a real emitter of light. So if we can take it and open it carefully, we can see that it emits infrared light. So there's no difference between a diode and LED diode. The diode, the simple one, produces infrared light that is enclosed inside some ceramic and is then translated into heat. That's the reason why diodes get hot, because infrared is transferred by heat. In this case, instead, these are produced and made to create the more light is possible. So if we watch carefully how an LED is made, we can see that we have two contacts that gets inside something that looks like a coffee mug, a very small one, and inside, in the bottom, there is a very small component that is called a semiconductor. If we change dimension or material of this semiconductor and we apply electricity, this starts to vibrate. I know it's not the real word, but you can imagine that it's shaking very rapidly and is producing photons. So that's the reason why we have light. If we change material or tension that we apply to the LED and of the semiconductor, we can then change the wavelength, and that's the reason why we can have the perception that the color change between one LED and another, because we have different semiconductor or different dimension or different voltage, and that's the main reason. So it's very interesting not only to know what's the difference between these, but also to know that there's no difference from an LED that emits light and a diode that doesn't emit visible light. So that's so interesting, but let's continue with the project. We are almost there.
For emitting light inside my giant LED, I choose this. This is a very powerful small LED chip. Inside of it, I can see with the macro lens we have 6 small diodes that are connected in series. I can remove the rubber coating that is covering the cables, so it's much easier now to connect them to 2 very small brass tubes. This will work like the 2 legs of the LED. I took some aluminum, cut it, so we have the same shape that is inside an LED classic one. So this is just for aesthetic reason, no real purpose for this. But now let's take this. This is a wood base with some gasket, and I can put 2 glasses container here on top. Inside the glasses I can pour some clear, transparent epoxy resin. This is made on purpose for creating little molds with a very transparent resin. I can use a syringe to make sure to have the right amount of each component. We have to put 60 parts of component A and 40 parts of component B. Pour everything inside a glass container, and it's so important to stir and mix the parts carefully. In this case, we aren't in a hurry because this reaction will occur in 24 hours, so we'll take our time to mix it properly. 5 minutes is more than enough, and I can use a drill with this component to mix everything together. You can see that the color has changed, not for a chemical reaction, but let me explain you better.
When I was trying to mix the two parts of epoxy resin using the syringe, some air bubbles get trapped inside the resin, and once I start to mixing it with the drill, these air bubbles destroy, and we are creating very small air bubbles. That's the reason why it changed color. It was perfectly transparent and now is a little bit whiter, and that's the reason why there are trapped inside very small air bubbles. This is terrible. I don't want to have a white mold. We are making a transparent LED, so we have to remove all these air bubbles, and the cheapest way to do this is taking an air compressor from a fridge, and here, let me show you.
It's possible to convert an old vintage motor fridge into a vacuum pump. From here compressor we have this nozzle that push air, and from this one instead will suck air. I connect this part to the wood board with a silicone gasket. On top of them I can put the glasses container, and once the pump is turned on we can suck the air from the bigger container. So the resin is exposed to vacuum, and all small little bubbles that are formed inside will start to expand, get on the top and explode. So this is the best way to remove all bubbles that are inside. Repeat this process almost 5 times. In half an hour we remove all these little bubbles. The thicker the resin it is, the colder the room it is, the more time it will take. So finally you can see that everything works, and I have a clear resin again.
We are almost ready. We have the negative mold and the epoxy resin. We can pour them together, but first it's so important to create like a little layer on the mold so that the resin doesn't stick to the mold itself, and it's much easier to separate the molds afterwards. So what I can use maybe is some bee wax. I can pour it inside and make it all smooth and shiny again. But I have here this spray, and it's written that it's made for don't let the parts stick to each other. It's the same, almost the same thing you can find on kitchen pans. So let's try it and test it if it works. Let's try it on inside the mold.
And now that the spray is applied, everything from the inside is so shiny that looks like glass component. The more shinier it is, the more difficult it will be for the resin to stick to the components. I'm using this flexible arm and this tripod head to mount and fix perfectly the LED centered inside the epoxy resin mold. So now it's just ready, and I can pour the resin, the crystal clear resin, inside the container. In this step it's so important to do things slowly. We don't want to trap air bubbles inside. Well, so difficult to remove them, so let it cure for about 24 hours. And now finally everything cured up, and yeah, just ready to take it apart. And this unfortunately took quite some time. Removing it, just pulling the two brass tubes is impossible because are glue inside. I try as well to squish the container, but everything seems stuck. I then realized I can use some compressed air, a very small needle, to push some air around the mold. But as well here I'm having so much trouble, I decided to destroy the mold and trying to push in the air here. But even this method that usually works in this case doesn't work. I use a hammer and also a chisel to try to apply some lever force to open the mold, but unfortunately the resin sticks to the resin of the 3D printer and looks impossible to remove the two molds.
I don't know why, but it sticks perfectly to the mold. It is impossible to remove the two parts. The epoxy resin sticks so well to the resin from the 3D printer. I was hoping so bad that the spray I use will solve this problem, but it didn't work. The plan was to make and fabricate a mold that I can use multiple times to fabricate multiple LEDs and start selling them. But unfortunately, this isn't the process. I have to find a way to have a mold that doesn't stick at all to epoxy resin, and I have something here on my shelf. Let me teach you and let me show you how.
So this is paraffin wax. I put it all inside an aluminum container and I will melt it using a heat gun. I design again the mold itself of the LED, and you find all the links I'm using for your 3D printer here in the info below. As always, I came out with all these polygonal faces and I have to use the lathe again to sand it in. But this time it was much easier and you can clearly see that everything is so shiny. It looks like something you can stick in your kitchen. So now I can melt the wax. I was telling you, is almost 3 kilos of wax and I can let it cure here inside. So now that everything is melted, I have to use my arm, my flexible arm I use to record videos, to fix everything properly in the center, perfectly at 90 degrees inside the wax, without letting it fall inside. Let the wax cool down for about an hour, and finally this is the result. I can stick the hand inside, apply some force and remove it from the wax itself. In this case, the wax is covered with a very thin and small layer of oil. Would be easier to remove it.
Wow, and the mold now, this time with wax, is perfect. I can remove this black mold, this is just for having the shape in the wax, and pour directly inside the wax the epoxy resin, the transparent one.
I learn new stuff, and maybe today I made huge mistakes, but from mistakes I learn new stuff. And in this case, working with very big volumes of resin can start to produce a lot of heat, and heat can melt the mold itself. So let's cross the fingers and hope that the resin I've used doesn't get hot while I was drying and curing. So let's take it away from the mold and cross the fingers.
And the color is so bright, and just as a normal LED, the light is perfectly directional in one single point. Tac! Mamma mia! No, vabbè, ragazzi. Non c-
Wow, bellissimo! Guarda che spettacolo!
I love the fact that this will be a design lamp for my shop in my living room, and this also will be a very nice gift idea for all my friends. So at Christmas I already know what to give to all of them. So let me know if you think you enjoy your project with a thumbs up. And I was also thinking to improve the project and changing the LED chip I put inside, make another one much bigger, much powerful. I'm talking about 100-watt LEDs, and choosing one with a perfect CRI, which is the color tone of the skin, so I can use it also to light up my face and having a great video. This will be a great video, a light video for my studio as well. So as always, I leave here where the blue light is, the previous video, which was how to make a plasma cutting machine at home with very, very cheap components. You find the link here. And also how to make a bamboo bike with very cheap parts. Yes, this is the only tutorial channel, YouTube channel. I'm talking about only things I make weekly. So if you aren't already subscribed, consider to subscribe to this channel, and see you soon. Ciao, ciao.